What is meant in molecular terms by the internal energy of a gas? So the definition is the sum of random and microscopic KE and PE of all the molecules. Part B. State qualitatively and explain in molecular terms what happens to the internal energy of a fixed mass of an ideal gas when separately the temperature of the gas is raised. So you just have to mention about the change in temperature. So you can say, when temperature increases, KE increases. Therefore, internal energy increases. So don't forget to add the last part about the internal energy. Alright. So second part, the volume is decreased at constant temperature. So since they did mention about temperature, so you should also mention that temperature is constant, so KE is constant. That's the first part. Now for the second part, the volume is decreased, right? So some people think, oh, volume decreases, so therefore separation decreases, so the PE decreases. Actually, it's a trick question because this is specifically referring to an ideal gas. So ideal gas, as we know, do not have intermolecular forces, so they don't have potential energy. So it's a trick. So you just have to say, ideal gas does not have PE. That's all. Alright, so that means first part you say temperature constant, KE constant. Second part you say ideal gas has no PE. Then write down the final conclusion, therefore no change in internal energy. And part 3, the gas as a whole is moving at a certain speed. So what they're trying to say is, at first your gas probably is in a container, which is stationary. Then you take that container of gas and you start moving it. So when you move it, does it mean that now it gains KE? So the thing is, when you talk about internal energy, we always talk about microscopic, or we say the energy of the molecules. So we are not concerned about the gas as a whole. That means if you take the gas as a whole object. Rather, we are talking about within that container, the molecules within it. So therefore, moving the container has no effect on the internal energy, because moving the container would increase the KE of the gas as a whole, but does not increase the KE of the molecules within that container. So here you would say that the KE of the gas as a whole is not part of its internal energy. Therefore, no change. And for this part, they mention that you only need to put a tick where the internal energy is increasing. So before we decide whether the internal energy increases or decreases, it is a good idea to write down the KE and PE here. So for KE, how do I know whether it will increase or not? We look at the temperature. And for PE, we look at either bonds or separation. So in this case here, they said water freezing at constant temperature. So constant temperature implies that your KE is constant. Now water freezing, bonds will be formed. Now when bonds are formed, we have learned that PE will decrease. But let's not forget that water freezes and actually expands a little. So we were saying that this is actually a special case. Normally, when a liquid solidifies, it actually shrinks a little bit. Except for water, whenever it freezes, it actually expands a little bit. Now this is due to the hydrogen bonds, all right, between the molecules, which create a lot of empty spaces when they are in ice. All right, the hydrogen bonds are when they are in ice. So therefore, the hydrogen bonds make them expand a little bit. So when this water freezes, we know that the separation increases. So it seems that the PE will increase. So some people get confused. They say, oh, okay, so does it mean that bonds form, PE decrease, separation increases, PE increases, so it cancels out each other? The answer is no. Now we have already learned that the change in volume from solid to liquid or liquid to solid is extremely small. So the change in PE due to the change in separation is actually very small. So this part, due to the separation increases, this PE is actually increasing very, very little. Compared to this, when bonds are formed, the PE decreases a lot. So whenever, right, you have a contradiction between the bonds and separation, we just have to look at the bonds. Now this applies to when ice is becoming water or water becomes ice only, because all other substances wouldn't have that problem. All right, so overall we would say the PE decreases. So PE decreases, KE constant, so you don't have to take this because overall the internal energy would decrease. Now the next one, the stone falling under gravity in a vacuum. When the stone falls under gravity, we all know that the speed will increase, right? It wouldn't reach terminal velocity. So the KE of the stone will increase, no doubt about it. But we are not talking about the KE of the stone as a whole, we are talking about internal energy. That means within that stone are the molecules vibrating faster or slower. That is what we are talking about, not how fast the stone falls. So therefore, again, it is not part of the internal energy. Now, when they say vacuum, right, it also means that there is no air resistance. So if there's no air resistance, it means that the stone will not heat up. All right, there's no change in temperature. So we only have to look at temperature. Don't worry about whether it's moving or not, the whole stone. Look at the temperature. So since no change in temperature, your KE is constant. All right. Now, similarly, when it falls, no doubt it will lose GPE, but the GPE is nothing to do with the internal potential energy. So internal potential energy depends on bond separation. So again, not affected, right? So there's no change here. Now, water evaporating at constant temperature. Then at constant temperature, we all know KE is constant. But what about water evaporating? What happens to the PE? Now, when water evaporates, no doubt the bonds will be broken. So bonds broken, we all know that the PE will increase. Now, at the same time, when water evaporates, it changes from liquid to gas. So the volume actually increases significantly. So also an increase in PE. So overall, PE would increase, no change in KE. So overall internal energy increases. Stretching a wire at constant temperature. So temperature constant, KE is constant. But when you stretch a wire, we know that the separation between the molecules get further apart because the whole wire is longer now. So separation increases, so PE increases. So therefore, the internal energy increases. State what is meant by the internal energy of a system. So we've already done that in the earlier question. So we go to part B. State and explain qualitatively the change, if any, in the internal energy of the following systems. Number 1, a lump of ice at 0 degrees melts to form liquid water. Now we can talk about the temperature first. So you say temperature constant, KE is constant. Now when ice melts, we all know bonds are broken. So you can say bonds are broken. So PE increases. Now once again, I want to highlight this. When ice becomes water, it actually shrinks a little because the hydrogen bonds which are in ice, when it breaks down, will enable the molecules to move into the empty spaces. So the volume actually decreases a little, so the separation decreases. So it seems that the PE here will decrease. So, but the bonds are broken, so PE increases. So when there's a contradiction, don't worry about the separation. The change in separation from solid to liquid or liquid to solid is very, very small. So we look at the bonds only. So we just say the bonds are broken, so PE increases. So therefore, internal energy increases. So 3 parts to this answer. First, you say temperature constant, KE is constant. Second part, you say bonds are broken, so PE increases. Then finally, you say therefore, internal energy increases. Now, you don't even have to mention about the separation, all right? You don't have to. Now, part 2, a cylinder containing gas at constant volume is in sunlight so that its temperature rises from 25 to 35 degrees Celsius. So here we can talk about the temperature, which is obvious. Temperature increases, KE increases. Now, what about the separation here? Now, since it is constant volume, all right, and they didn't mention that this is an ideal gas, all right, so we can't assume that it is an ideal gas. There's no PE and stuff like that. We can't assume that. However, since volume is constant, so it means that the separation is constant. So we can therefore conclude that the potential energy does not change. The second part will be PE is constant because separation is constant. And then finally, the conclusion, internal energy increases. So 3 parts to the answer. First, you say temperature increases, so KE increases. Second part, you say no change in PE because separation is constant. And then finally, you say therefore, internal energy increases.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with 1 or 2 past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. Genius Hub will get genius teachers to fulfill your request for the solution. Genie, we'll see you next time. Bye-bye.